In this video, we're going to look at two very specific functions. So let's begin. Use the equation k equals t minus 3 to fill in the table. Okay, it looks like t has been left up to us to decide what to do with it. I don't know. What do you want to pick? T is, making something up, t is 2. Okay, well, when t equals 2, 2 minus 3, let's write this down. K equals 2 minus 3, that's -1. Got it. I don't know. How about 4? I realize I'm picking even numbers. It appears as though I like those. I favor those. Let's see. If t is 4, our rule says subtract 3. So 4 minus 3 is 1. Okay, so this rule is really saying take whatever you're inputting and deduct 3 from it. Okay, we can do that. If I had 10, I would deduct 3 and I would get 7. If I had 0, I would deduct 3 and I would get -3. I'd be in debt. Write down 3 ordered pairs that satisfy this equation. Okay, I got some business right here. 2 corresponds or is coordinated with -1. The value for t equals 4 is coordinated with k equals 1. Did I say -1 over here? I hope I did. The value t equals 10 corresponds or is coupled with the value k equals 7. And the value for t equals 0, that is related to the k value of -3. Got it. There are my pairs, my couples. Is this a function? Yes. For each input of t, there was no more than 1 output for k. For each t value, there was 1 k value. And that's how we know it's a function. Put the graph of the equation here. Okay, I have some values. 0, -3. I'm counting by ones, so let's see. 1, 2, 3, 4, 5, 6, 7. That would be 7. That means probably 7 tall because it looks like a square. All right, 0, -3. Got it. 10, 7. Well, I'm going to skip that one for now. 4, 1. 1, 2, 3, 4, 1. Got it. 2, -1. 1, 2, -1. It's looking pretty linear. Okay. You know what? I'm going to use my handy Post-it note and connect these dots. Okay. Got it. Okay, put the graph here. Done. Write down 3 ordered pairs that do not satisfy the equation. Okay, we can do that. So I'm going to put these in red. Do not satisfy this equation. So I don't know, when t equals 2, we know that what satisfies this equation is a k equals 1. -1 equals 2 minus 3. So I don't know. That doesn't work. If we input 2, we don't get 0. So t equals 2 does not correspond with k equals 0. I can make up several of these. Infinitely many, I would say. Anything, so right here, so I just said when t equals 2, that does not work. How about when t equals 0? We said k should be -3. I don't know, 10. Way up here. Didn't work. How about 0 and 1? When t equals 0, k does not equal 1. When t equals 0, It's k equals -3. It's not 1. 1 does not equal 0 take away 3. So anything that is not on this line ends up being an ordered pair that does not satisfy the equation, so is not a solution. Write down the ordered pair that satisfies the equation at the point when the graph is on the horizontal axis. Okay, horizontal. Okay, that means like this, running left to right here. And here is the point where our line, which is slanting upwards, hits that left to right axis. Let's label it. Oh wait, that is our t. Our horizontal is actually the t variable here, and our vertical is k values. Got it. Okay, so write down the ordered pair. This ordered pair would be a t of 3 and a k of 0. T of 3. Oopsie. I just wrote down what was happening in my brain, which is a k of 0. And I meant to say that out loud instead of write it. So there you go. There's the ordered pair of T3, K0. Is this where T is 0 or where K is 0? Oh, so just to give these quick label, this is T and K. This is where K is 0. So if K is 0, we're on the horizontal axis. Write down the ordered pair that satisfies the equation at the point when the graph is on the vertical axis. So we look at the K axis, which is running up and down, and this point right here on our line that meets that. So where is that? 1, 2, -3. So this coordinate pair here is 0, -3. And just to write down what we're keeping track of, that's when T is 0 and K is -3. So when T is 0 and K is -3. Is that when T is 0, K is 0? T is 0. Okay, so if the T value is 0, then we actually hit the vertical axis. Our graph does anyway, right there. Okay. Let's look at factory equipment. Let's get more specific. A piece of equipment in a factory depreciates over time. As time goes on, the value of the equipment is given by the function V of t equals 2000 minus 100t, where the variable t is the number of years used on the production line. Compute V of 0 and interpret what it means. Gotcha. Will do. So this notation, remember, doesn't mean V times 0. It means this t value is our input, and we are computing how much this piece of factory equipment is as time goes on. So t equals 0, 2 grand minus 100 times 0. So V equals 2000 minus 100 times 0, which is 2000. Okay, I'm going to interpret this. Well, T is number of years in use of production. So, okay, if we have not used it, it's brand new. The equipment is worth 2 grand before being used. Got it. Compute V of 10. So here t equals 10. And then v would be 2,000 minus 100 times 10. 10 100s is 1,000. So 2,000 take away 1,000. 1,000? The equipment is worth $1,000 after 10 years of usage. All right. What does the minus 100 represent in the equation v of t equals 2 grand minus 100t? So I feel like this is how much it's going down. The t is representing the number of years of use. I'm going to grab a quick drink of coffee. So the t is the years, but this negative 100, I feel like that's how it's depreciating. So what does this negative 100 represent? This negative 100 represents the depreciation rate. Okay, or more, quickly, it goes down in worth $100 per year for each year it's used. That's how it's going down, the value of it. What does the 2,000 represent in this situation? Well, that's what we did that in number 1. It's worth 2 grand before being used. So 2,000 is worth $2,000 initially before it gets used. Okay. Couple of quick remarks, and then we'll do a new video to talk about some formulas, because I feel like this could be viewed as a formula for sure. V of t, let us know value is a function of time. And we really do use the word function there. This notation was specifically chosen to say that for every input, there was no more than one output, and that output was value, and that input was time. So this v of t lets us know that value is a function of time. Okay, and this could have been more vaguely written. Okay, we could see y equals 2,000 minus 100x. But I'm not gonna lie, I really do prefer v of t, and because as a reader, if I read this in some article or newspaper or research, I would not know what the y and the x represented. But if I saw this, v of t equals 2,000 minus 100t, I would be like, oh, maybe v stands for something related. And then my eyes would hunt for the word value, and it would find it. And then maybe t stands for time. I mean, it can stand for other things like temperature, but immediately you see that is correct. So, it's true that we can be vague and abstract and label this with y and x, but I really do think it's more appropriate to be kind to a reader to let them know exactly what you're talking about. It just avoids confusion. In the last video for this section, we're going to talk about formulas and using those.